In this video, we are going to talk about confidence interval and hypothesis testing. In chapter 7, we talk about the confidence interval of mean, proportion, and variance. For the mean, we discussed two different cases, right? So we did the confidence interval of mean when population standard deviation sigma is given, and the other one was the confidence interval of mean when the population standard deviation sigma is not given. Okay, and in chapter 8, 8.1, 8.2, 8.3, and 8.4, we did the hypothesis testing of the mean, hypothesis testing of the proportion, and hypothesis testing of the variance. Okay, so what is the difference? What is how they are related? Are there any relationship between the confidence interval and the hypothesis testing? Actually, there is a strong relation. What I mean by that is, so we can actually test a hypothesis using the confidence interval. Okay, we can use confidence interval to test a hypothesis too. That's what we can use confidence interval to test the hypothesis. Let us see the relationship. When the null hypothesis is rejected in a hypothesis testing situation, the confidence interval for the mean using the same level of significance will not contain the hypothesized mean. Meaning, if the in the hypothesis test, if we reject the null hypothesis at that time, the value of the null hypothesis does not fall in the confidence interval, but we should use the same level of significance for the confidence interval and hypothesis testing. Okay. Likewise, when the null hypothesis is not rejected, if you do not reject, then the confidence interval computed using the same level of significance will contain the hypothesized mean. What does that mean? Let us see an example, and then we'll do. So I will find out the confidence interval directly from calculator. I will test the hypothesis directly from calculator, and I will show you the relationship between those two. Okay, because we know how to do them by traditional method or the without using calculator, right? We know how to do that using the classical method or the critical value method. We know that how to do that, but I want to show you how to do by calculator for both. Okay, let us first list the given thing. In example 1, a sugar is packed in 5-pound bags. An inspector suspects the bags may not contain 5 pounds. A random sample of 50 bags produces a mean of 4.6. See? And the standard deviation is 0.7 pound. Is there enough evidence to conclude that the bags do not contain 5 pounds as stated? Okay. Also find the 95% confidence interval of the true mean. Assume that the variable is normally distributed. So I'll do the 95% confidence interval right here on the right side. Okay. So I am going to do 95% confidence interval here, and then confidence interval. I will do hypothesis testing here. Okay. Okay, let us list the given thing first. So it says an inspector suspect. So sugar is packed at 5 pounds bag. So we are talking about the average here, right? Because it says the mean is 4.6 and standard deviation is that. And so mu is 5 pounds. N is 50. And there are 50 samples, right? And the x bar is 4.6. Standard deviation is sample standard deviation, so we do not by s, because it is talking about the sample and then sample mean and sample standard deviation. So is there enough evidence to conclude that the bag do not contain 5 pounds as stated? So it is mu not equals to 5 is the alternative hypothesis, right? Okay. And then alpha is 0.05. Okay, and then also use 95% confidence. We will do 95% confidence interval separately here. Okay, so let us use calculator to test the hypothesis here. So how do you do that? You do H0 is mu equals to 5, H1 is mu not equals to 5, that will be H1, right? Because it is the two-tailed test. And find out the test statistic. It is x bar minus mu over s over root under n. Right, that's what you do. And to find out the critical value, we need to use t-test, right? Because we need to use inverse t. Or if you want to do the p-value, then you need to do this 2 times. So 2 times the area right of or the left of the test value, right? and we decide that way. Okay, so let us do all these things using the calculator. So let me turn on the calculator here. So let me erase what I have. So first of all, I want to do the t-test, okay? Because this is t-test. Why? Because sigma is not given. S is given. Sample standard deviation is given. Population standard deviation is not given. That's why we will be using S here, okay? But if you use sigma and S, you will get almost the similar result because the N is, the sample size is big enough. Whenever sample size is big, then the G-test and T-test almost give you the same value, okay? Or the area under the normal curve, G curve, or the T curve will give you the same value. Okay, let us do the hypothesis testing first. So go to the stat, and then go to test. Okay, we want to do t-test. Hit enter. All right, we have the statistic. Go down. Mu 0 is 5, right? That is 80. And what is x bar is 4.6, 4.6. What is S is 0.7, right? And then what is N? N is 50. N is 50. And it is left tail, right tail, or two tail? It is two tail, not equals to 5, right? And you calculate it. What do you get? You get T is the test value is negative 4.04 and P is 1.87 to the 10 to the negative 4, right? So the test value T is what was T? Negative 4.04, right? Negative 4.04, right? And what is the P value? P value is equals to 1.87. Let me look at again. 1.8756. Okay, oh, you can do 57 times 10 to the negative 4, right? So what does that mean? 10 to the negative 4. You can write this as 0.0001. See that decimal. So this should start 10 to the negative 4 means there should be there should be 4 digits before that decimal, and then you move that decimal to there, okay, at 875. So what is that P value less than alpha or greater than alpha? It is less than alpha, right? Because it is 0.0001 and alpha is 0.05. So we reject 80. Okay, let us find out 95% confidence interval for that. Do you remember how do we do that using calculator? So what we do is go to the stat, test, and then we'll go to t interval because it is t-test, t interval, right? Because we don't have sigma given. Oops, sorry. So we need to go to so we need to go to calc and then test, and you will go to t interval. Okay, number 8, I guess. Yes, t interval. Hit enter, and we have a start. X bar is 4.6, sx is 0.7. Actually, it is copying from the t-test. Okay, n is 50. We have that. And then C level is 0.95. Okay, so so basically we go to calculate, and I got 4.40 and 4.79. Okay, so 4.40, so 95% confidence interval is 4.40 and 4.79. Look at that. What does that A say? When the null hypothesis is rejected, we rejected the null hypothesis here, right? When the null hypothesis is rejected in the hypothesis testing situation, the confidence interval for the mean using the same level of confidence. Look at that. What was alpha equals 0.05, right? And in the confidence interval, what we do? We do 1 minus alpha is 95, right? 1 minus alpha is 0.95 because 95% confidence interval means 1 minus alpha is 0.95. So we are using the same significance level, okay? Here we got the confidence interval between 4.4 and 4.79. Then it says, if you reject, then the true mean or the population mean does not contain the hypothesized mean. The confidence interval does not contain the hypothesized mean. Look at that. This is confidence interval. Does it contain the hypothesized mean? This one. Does it contain the null hypothesis there? No. Because null hypothesis is 5. It is not containing here. Okay. So how do I use the confidence interval for the hypothesis test is, if you want to use confidence interval for the hypothesis testing, what you do is find out the confidence interval and then see if the null hypothesis number in the null hypothesis fall in that interval or not. If the number in the null hypothesis fall in this interval, then we do not reject the null hypothesis. If this number does not fall in here, this number does not fall, then we reject the null hypothesis. That's what we do. Okay, that's what this A was saying. Likewise, when the null hypothesis is not rejected, if you got the result that does not reject, then in that case that the value in the null hypothesis will fall in the confidence interval. Okay, let us do another example. Okay, let us do example number 2. First of all, we will list all the given things. Okay, according to a public service website, 69.4% of the caller criminals get prison time. This is percentage, so this is for the proportion, right? So what is P? Is 0.694. A randomly selected sample of 165, n equals to 165. White collar criminals reveal that 120 were serving or had served prison time. X is 120. Test the conjecture that a proportion of white collar criminals serving prison time differs from 0.694. It is two-tailed because it says differ from, it's not equals to 0.694. Okay, so alpha is 0.05. Okay, again we will do the test here, hypothesis test here using calculator. Okay, so we will do that. So hypothesis testing and then confidence interval. Okay, and we will see that. Okay, so by the way, one of the things that in this book we did not talk about the one-sided confidence interval. We have the two-sided confidence interval only, meaning we set it on the both sides, right? We will find out the left limit and right limit as the finite number. But it is possible to find out the one-sided interval. One-sided 95%, left-sided 95% interval, or right-sided 95% interval. In that case, one of the limit in the confidence interval will be infinite. We did not discuss this. This book does not, or this course does not discuss that left interval or the right interval. That's why both of the examples I am taking are the two-sided. Okay, so let us use calculator to enter that. First of all, okay, by the way, so this is a proportion test, right? P is the proportion test. So you need to pick the right test there. So go to stat and then test. So one proportion Z test, what is that? Is number 5, right? Let's enter that. So what is 80 is 0.694, 0.694, right? What is X? X is 120. And what is N? N is 165. Right, and it is two-tailed, so hit enter and then go and then hit enter to the calculate. So what do you get? P value is 0.3536, right? G is 0.9274 and P value is 0.3536. Okay, so 0.3536. So G is the test value. Okay, G or T, and then P value is 0.3536. So P value is greater than alpha, so we do not reject. We do not reject 80. We do not reject 80 means what we should get here is that 0.694 should include in the 95% confidence. But let me copy what was the test value there. We denoted by G or T. That was 0.9274. So 0.9274. So what I am going to do next is I am going to calculate the confidence interval. So what was alpha? Alpha is 0.05 and I will do the 95% confidence interval, 95%, because alpha is 0.09 means 1 minus alpha is 95%. So that's what I am going to do. Let us do that. Go to stat and then test, but it is one proportion G interval. Okay, one proportion G interval. Let's see, one proportion G interval is in A. Hit enter. And you have X is 120, N is 165, and then confidence level is 0.95. We have everything copied from the test to proportion test. So you got 65927932. 6592. So 0.6592 and then 0.7. What was that? 0.7952. 7952. See? Is this falling there? Is this P value fall here? The answer is yes, because 0.69 is bigger than 0.65 and smaller than 0.79. That means, so you can actually use the confidence interval to test whether we reject the null hypothesis or do not reject the null hypothesis using the confidence interval. Because in this case, the P value, or not P value, the null hypothesis, this is H0, right? This is H1. The null hypothesis fall in the confidence interval, meaning we do not reject the null hypothesis. If it doesn't fall, we reject the null hypothesis, like in the previous example. Okay guys, this much for this chapter. Okay, so we have one more chapter left, that is chapter 10 will be in the next chapter. Okay.